Hello, my name is Samantha Billington, and I work with a company called TurnItIn. In the fall of 2014, we moved from Sloaney to streaming replication. Yay. That's a big deal. And in doing so, we encountered a lot of bumps along the way. One of those was streaming replication lag, which we didn't expect, because coming from a Sloaney world where you built safeguards into your application to stick to master because you don't actually know if your data is going to get there soon or not, we had really high hopes that streaming replication would solve a lot of problems. And it turned out that it was a little bumpier than we had planned on. And what was worse is there wasn't a lot of information available about what was going wrong. So we started looking for case studies, people that had done these things, problems, and there just wasn't that information. So that is why I wrote this talk, is that so other people who experience these things can go look it up, they can Google this, and they can find answers. So the first problem we encountered was, how do we know what's going wrong? Monitoring 101, we should all have this set up for everything in our database already. Cacti, Nagios, Zabbix, PagerDuty. This should already be in existence. Simply put your lag monitoring into it, and you're good. This is my go-to, which is the typical go-to, for what's going on and let me see it now. Just monitor your slaves directly. When you get into the database, look and see how many are there, what are they doing, what's going on. So the other question is, what is normal? We have a very high workload environment where we never go a second without data passing between the master and the slaves. It's incomprehensible. In slower environments, that's absolutely possible. So what can appear to be lag is actually just a lull in normal traffic. To get around that, a rep table, timestamp, make sure that your master is passing something to the slave, read it on a regular basis, know that your master is still getting something and you're not just in a normal downtime. Time lag versus byte lag. Let's talk about time measurement first, because while they represent two different types of problems, they're very closely related, and one might not give you the answer that you're looking for. So to monitor time lag, you first have the case where your slave is absolutely up to date with your master. So if the receive location, master, is the same as the slave reported replay location, you're good. Everything's there, nothing's wrong, report 0, no lag. Otherwise, you're gonna go to your slave and tell me the last transaction replay timestamp, which is the timestamp that transaction occurred on the master, and how long ago was that? This is what looks like normal, at least in our case. There's a couple of spikes here, up to 3.5 seconds. Those are fairly rare, but all in all, perfectly normal. This is also normal. So regular, once a day, peaks. Any clue what those are? Exactly, those are backups. It is surprising how often someone will look at this graph who is not a DBA, who's not in operations, and go, oh my God, the service is lagging, what's wrong? And nothing's wrong. They're looking at a designated backup host. That is something that socialization helps. So you need to make sure that everybody knows what they're looking at. Perfectly normal. That's also normal. Any clue what the second spike is? One large spike every day, followed by a secondary spike. Nope. That is a secondary database being backed up on the same server. And on that same token, we have had people that were DBAs look at this and go, I don't know what's wrong. And burned time proving that that was a secondary backup. So communication is one of your first hurdles into normal. Replication being paused is what causes those spikes. You cannot take a PG dump off of a slave without pausing replication. You will cancel your transaction because it interferes with the replay of the logs. So let's move on to byte measurement. So this is the standard, what is the diff between the sent location and the replay location. Very, very standard, check from master, gives you the total amount of bytes that the slave is lagging. That's what looks like normal for us, at least in our case. Some periodic spikes, one that looks, kind of nasty compared to the others, but no service interruptions, no issues from the client side. Everything appears fairly normal. This is a comparison of byte lag to time lag. So very similar to the same exact time period. You can see the peaks comparative here and here. And while they measure two different things, they both give you an amount of issue that you can have on the front end. So it's really important that you look at both things. We have had issues where, say, our load balancing between the slaves would mark slaves as behind and pull them out of the pool, causing issues, where in fact they were totally fine as opposed to their byte lag. So the amount of data behind versus the time of data behind actually does make a difference. Humans don't typically think in byte lag. You don't freak out and go, oh my God, my slave is a million bytes behind. But looking at it can calm you down if you see the time versus byte and know that it's actually not such a big deal. So what's actually going wrong? We found that once we tuned our system, of course, most things were okay. It was in the setup, the initial phases of figuring out configuration, figuring out our hardware. That was where all the bumps came into play. We had three main issues in determining what was going wrong. The first being configuration, how we had set Postgres itself up and the various values that we were tuning there. Hardware. Are you on SSDs? Are you on spindle disks? Do you have partitioned xlogs away from your PG data? If you're on VMs, I'm just sorry. There's a lot of this is tuning your hardware at a level that you don't necessarily have access to when you're on, say, AWS. And thirdly, human error. We had a very good case, and I say good in a bad way, where there was a hand-changed value for async versus sync, which I'll get into in a second. And when our CF engine at the time was what we were running, changed its value everywhere else, moving from synchronous to asynchronous, the one that had been hand-changed did not get changed. So a little while later, we came across that slave actually stopping its master from applying logs, hence a huge outage. So async versus sync. If your slave can take down your master, you have a problem. While this is necessary for, say, banks or other institutions that absolutely have to have the durability of knowing that their slave is a full copy, if you can take a couple milliseconds of lag, it will greatly add to your stability. Another thing that you will absolutely need to do is isolate your traffic. We have reporting hosts, and then we have our normal read hosts. So in our cluster, there are at least 3 servers, 2 to take read. We're obviously a read-heavy application. And the third, to take all those long-running reporting queries. It has separate configuration for the Maxwell archive delay, streaming delay, and that allows those queries to not be killed as they would on the normal application read slaves. A couple of things that you might want to consider isolating: your FDW traffic, your report slaves, as I mentioned, are cron hosts. Very long queries delay the application of logs and therefore making all of your other queries wait, and relay hosts. So if you have a DR cluster that is fed from a relay host in your primary, that strain on your replication host is going to cause a little bit, not a huge, but a little bit of extra I/O, and that can be just enough to cause lag. Another gotcha, if you're running 9.4, who is running 9.4? Isn't 9.4 the most awesome thing ever? Don't forget to remove your replication slots. If you don't, your master will hold on to your xlogs until it fills up the disk. And that, of course, is a rather catastrophic failure. So don't do that. Write a script to remove a slave. Go through the process a million times, but don't forget to do it. And configuration. These are the two primary things. Well, there's one more. These are super important in configuring your replication. Do we know why? So let's look at them one at a time. Max standby archive delay applies as while data is read. So your slave will receive all the xlog data, but it's not actually going to apply them to your slave. So you receive them from the master, you're not going to apply. That means that your last received timestamp is still going to be where it was on the master, and you're going to receive lag. The other side of that is the streaming delay, which actually has the slave tell the master, stop, I can't receive that right now. So your slave is not getting the logs. In the event of failure, you're not going to have that data to replay. You're going to have to go back and receive it again. This is a fun one. Replication timeout and wall status interval. The wall receiver status interval is the interval with which your slave tells the master, hey, I'm still here. This is where I'm at. It's your status reporting. The replication timeout is the amount of time it takes your master to take a slave out of its normal reporting. So in the case of, say, a network hiccup, what happens when a slave doesn't report back and the replication timeout interval passes? Bueller? Yes, you go back to your select star from PGStat replication and you don't see your slave. So it is a case where your monitoring will not continue to look at your slave because it has effectively taken itself out of replication. The good news is, when a slave wakes up for whatever reason, say network hiccup, like has happened to us, it can come back and pick up right where it left off. Hot standby feedback. This is the single most important variable in your configuration if you're going to have read slaves. I shockingly have come across a number of people who don't actually use their slaves for reads. My God, you guys are a quiet audience. If you don't use your slaves for reads, do not turn this on, because there's no reason for it. The purpose of this variable is to have your slave tell the master, do not clean up records, I'm in the middle of reading them. Without that, you're going to get canceled transactions where your slave tries to apply wall logs to a transaction that is in process of reading them, sees the conflict, and kills your query. So the effective way to use a slave as a read is to enable hot standby feedback. Now the downside of that, no. This is such a controversial variable. I'm so surprised. The downside of that is bloat on your master. So you get a buildup of deleted tuples that aren't able to be cleaned up because your slaves are in process of reading them. The reason that this is default set to off is because of the danger of bloat on the master. It's incredibly important, and I think under talked about, that if you're going to use read slaves, you have to turn this on. Hot standby feedback plus max streaming standby delay. What's that recipe? I mean, obviously, I've given you the answer. There is the case, and I had a lovely story about this at a meetup not long ago, where hot standby feedback was enabled on because there were read slaves, and the max streaming standby delay was set to 30 minutes. So let's review that for a second. Your slave tells the master, don't clean anything up, I'm working on it. And at the same time, it doesn't apply any logs, or it doesn't even allow logs in for 30 minutes. I'm shocked. What this creates is an area of time up to the amount of time you set your standby streaming delay where you're not going to receive any data, period, point, end of sentence. Don't do it, or be very, very careful about it. Do this on your reporting slaves. Hot standby feedback is the one variable that can affect your master from a slave. Nothing else you do is going to affect it but this, and this can cause serious issue. So let's move on to hardware. You guys are very quiet. SSD logs and trim. If you are in a high volume environment where you have partitioned off your PG xlogs, which you should, even if you don't think you need to now, it's good practice to do this. Separate your PG data and your read load from the I/O of your transaction logs. If you do this on SSDs, SSDs notoriously are bad for writes, and SSDs degrade over time. This is a well-known issue, and I believe was touched on in the last talk. Trim will enable large batches of deletes from your SSDs to be much more efficient and extend the lifespan. So if you're mounting your xlogs onto SSDs, do so with trim. So this is all the fun stuff. These are all the issues that we came across when we made this move from Sony to streaming. This is the very first thing we found. So irregular spikes. This was by far the second hardest one to diagnose as well. The penultimate problem. Irregular spikes. This was on a slave that had 0 traffic. It was simply set up as the guinea pig for streaming replication. All the other slaves in the cluster were Sony. And for no traffic, seeing 25 to 30-second spikes is rather remarkable. So what would be a first stab at that? You have no read traffic. There's nothing else going on this box other than receiving your transaction logs and applying them. That machine was an older machine, and while it was still relevant to the cluster, it was not quite as beefy as it should have been, and simply applying the transaction logs on a spindle disk was enough to cause that. So watch your hardware, watch your I/O, tune very carefully. Again, if you're on VMs, I'm sorry. Super important. And this is my absolute favorite. This happened for quite a while, and when we saw it first, if you notice, there's a very, very slight rise there. You know, there's the outlier peaks that go up to 20 seconds there, but these are 10-second spikes. And these are after we partitioned our transaction logs, we were seeing regular 10-second spikes. Any clue? Again, this machine had 0 traffic on it. It was actually our next-gen hardware, so it was beefier than the servers that we had in production that were taking reads, and still had very regular, but on an irregular basis, very frequent but irregular spikes. This went on for a while. Let's look at it over 3 weeks before we figured out what was going on. And mind you, part of that was because we weren't sitting there trying to figure this out day in, day out. This was a monitoring, this was a tuning, this was let's watch it and see if we can figure it out. So long term, we started to get the picture of what was going on. Any more ideas? This is a great problem. This is an awesome problem because there was nothing apparent. No read traffic, and thoroughly confusing. Absolutely nothing. Brand new hardware, beautiful hardware, no load. There's our pattern. It's going up rather drastically. This is obviously clearly something we can't put into production under this, which is stopping an upgrade for all of our production hardware. NTP. So with the upgrade of the hardware was also an upgrade of the OS. And the upgrade of the OS, CentOS 6, did not read the configuration for NTP in quite the same manner, which meant that we were falling out of sync. So there was no actual lag. This was a reporting error. 3 weeks, tons of issues, reporting errors. And mind you, NTP looked like it was fine because it was running, just wasn't able to actually grab time. So this is another fun one. I can see my version of fun is not necessarily your version of fun. Negative lag. So that big red line is 0, and those spikes are the slave being ahead of the master. Now, how is it possible that our slave predicted the future? But even if you can get it to the slave incredibly fast, you can't do it before it was generated on the master.
Yeah, I had the same issue when I tried to get the xlog location on the master and on the slave at the same time.
Mm-hmm.
Due to whatever network activity issue, it takes a little bit longer to connect to the slave,
Mm-hmm.
which means the start and end of play is actually taken at a later time compared on the master.
Basically, the timestamp on the slave is ahead of the timestamp on your master. So NTP clock skew, same issue that took us 3 weeks to figure out before. When you look at the query to grab your slave lag, what you're looking at is the last transaction replay timestamp of the transaction when it occurred on the master. So you're saying, take that slave time, subtract a time from the master, and if your slave is ahead of your master, you get negative lag. So what is that? We are running really, really ahead of time because normally this talk is very interactive, but you all are so quiet today. So what is that 500-second abnormal spike? No? 500 seconds is a lot. No, network resumed. I mean, unless it was a jiggly network cable, and wow, that really just doesn't happen with modern hardware. It's not worth it. And sometimes you just have to say that the time we spent debugging something for a one-time anomaly doesn't really matter. And you just move on because there are other problems in the world, and this isn't necessarily your most important one. So this is normally the time where we talk about all our war stories. I've heard plenty of them. My favorite, I guess, was an Amazon issue where the disks at the Amazon cloud failed. So another VM problem that wasn't easily apparent because obviously you can't monitor for Amazon, but you can monitor your own, as well as the max streaming delay versus the hot standby feedback. So no issues with lag. None of you have done this. None of you have tuned your slaves and set up all your master configuration. How many of you are actually running streaming replication?
Will be next week.
Congratulations. And what are you moving from?
So right now we're actually hosted by Heroku.
Mm-hmm.
So this will be the first time we'll be pulling it back sort of in-house, but more like it'll be on Amazon, but under our direct control, not through Heroku. So we've been going through and planning out a model like more replicas and like a business intelligence reporting server. And so for that one, which will get very few queries, I'll need to make sure some of your settings are adjusted for it. That's what we're looking at.
These are all the problems that we are trying to address. So the move was onto Amazon, and watch your I/O. That's primarily, once you have the configuration issues that we've talked about with your streaming replication delay, your archive delay, hot standby feedback turned on, I/O. I/O is your primary issue. Watch it like a hawk. SRD, which I learned from Adam, I/O stat, and graph all that. Graph everything, graph it, watch it, make sure you can see it, because nothing helps more than visualization on this. And if you don't know, it's probably your hardware. I mean, unless someone is sitting in a corner not admitting something that they did wrong to configuration, it's probably your hardware. Yes?
Did you guys start off using the replication slots?
No, we added replication slots. We went from 8.4 to 9.2, and then from 9.2 to 9.4, and we just did that in August. So with the switch up to 9.4, we added replication slots. So the question was, has that been smooth, or the gotchas with that? We love them. It allows you to minimize the amount of, so the amount of xlogs that you keep on disk previous to 9.2 was a set variable that we had configured for our situations, at least at 5,000, which was a couple of days worth of buffer time. And if you turn on replication slots, you can shrink that down. So the time that you have, well, the space you're taking for your xlog partition can be drastically smaller. The gotchas that we found immediately were, don't forget, as I mentioned, if you take a slave out of rotation, if you decommission a slave, you have to go drop that replication slot. Otherwise, your master is just going to hold on to those logs, and you're going to fill up your partition. The other thing is we have an automated slave build. So whenever you build a new slave, we have the full script that goes and creates the replication based on the host name of the slave, and then goes through the rest of that. If that fails and the script retries, or say for any reason you want to rebuild a slave that has already been in rotation, you need to make sure that your script for building that slave cleans up after itself. So the very first thing that we do is we remove a replication slot for the slave we're trying to add. So that way it can be rerun without issue. Yes?
How did you end up discovering that your issue was NTP?
How did I discover that? Oh, so the NTP issue, I think that was discovered because I simply noticed that the machine was a couple seconds behind. I ran a date on it because I was trying to debug the lag problem, and did a now, and noticed that now wasn't actually now. Other than stumbling, and you know what, I didn't even put it together at that point. It wasn't a, hey, this is affecting my lag monitoring. It was, we need to fix NTP. And once we took a couple days for ops to figure out the NTP issue, the graph went down to 0. So via that, it was, oh, that NTP issue, that's what solved that. So backing into a problem, or backing out of a problem, I should say. So, but that one was fun. And that, when I give this talk, that problem is the one that everybody gets excited about, and no one can actually figure it out. At the meetup, we had someone after about 5-10 minutes figure that one out. Yeah. So, yes?
It seemed like a lot of the slides you had for hardware were kind of leading to where what we kind of recommend when provisioning read nodes, which is to run the exact same specs and exact same OS. So are you guys still running this different spec hardware and different OS?
So no, we're running all the same hardware right now, -1. And why that is that, so the question, let me repeat, is running different hardware is often the cause of a lot of these problems. And it's often the cause of many, many problems, not just lag. But it never stops that you have to upgrade hardware at some point. At some point, whatever you're running, usually 3 to 5 years in an enterprise situation, is going to become dated. So the NTP issue, for instance, was an upgrade. It wasn't that we weren't running all of the same hardware, it's that this was our next-gen hardware that we're proofing out and debugging before it goes in. So it was the perfect time to find these problems. It was the time when we needed to suss all of that out, and we didn't actually. There's another talk where I have a I/O line of death because in this next gen, we've added 2 hardware RAID controllers, AdaptTech controllers, one for PG data and one for the system drives and for the transaction logs. And the AdaptTech controller that the PG data partition was on had a driver failure and panicked. So all reads from the PG data partition completely failed. And that caused about 3 hours of downtime because this was pre-9.4, so you couldn't fail over without rebuilding slaves. And this proceeded to happen on all 3 production servers within 24 hours on a weekend during peak time. So the more proving that you can do to your hardware and the more rigmarole, the better. Yes?
Do you have a process to automatically take out replica from certain peak traffic when it's lagging behind too much, or when it's down, flat down, for example?
I missed part of that. Do we have a process to automatically take out slaves that are lagging?
Yeah.
Yes, we use HA proxy and PG bouncer, but HA proxy is the piece that with the ZynetD, we are monitoring both time and byte lag. Because originally, monitoring time lag, this is why both pieces are important, slaves would get marked down erroneously. So both time and byte have to go over a certain threshold for us to actually take a slave out of rotation. Running HA proxy currently, we're looking at moving that onto internal load balancing on our F5, however. Does that answer your question?
Yeah, kind of. For example, if you have a new replica, how is it going to be added to HA proxy?
So we'll add it into the configuration for the haproxy.conf, and we'll roll that out via automation. So we will update our HA proxy config on our load balancer class servers and roll it out via Puppet.
Okay, so you still have to go into Puppet manually, add it from there, and then
Right, we don't have any automation around adding a new server into the actual read layer. That's a way heavier operation than just switching servers out underneath. Yes?
I have a couple of questions. How many slaves are you running per master? Is it typically just one?
So the question is, how many slaves are we running per master? No, it's not just one. We have a full production cluster, and the production cluster has currently a master and 4 slaves, and one of those slaves is a relay host to a DR cluster that is a master and 2 slaves. And the extra 2 slaves in our production cluster are for emergency backups.
And then a follow-on question. You mentioned that you had bad experiences with Postgres and AWS. I can never understand some of that. Have you ran or tested Postgres instances in local hardware VM?
So let me preface that. A lot of the AWS examples that I were citing were not this company. We do not run in AWS for our Postgres. We're bare metal. And so yes, to answer the second part of that, all of this data comes from bare metal hardware.
Okay. And have you, or is it just the way that you like to run things?
Well, the company is 15 years old, so it's not necessarily the way that we like to run things. It is that the size of our master and slaves are very, very large, actually not even available in Amazon for the resources that we need. And we've had our own data centers since the company inception. So it is a process of virtualizing, and some of our databases will probably get moved onto virtual hosts, ones that are not quite the same load, but not all of them. Bare metal is still the most efficient for large volume databases that require, more than 144 gigs of RAM, and in our case, we do. Yes?
Yeah, so on AWS, we have a problem with using 9.39. The replication, it breaks every 2 months. So what happens is the streaming replication seems to break, and then they go back to replying the archive log files. And sometimes that breaks and it doesn't recover. It happens every 2 months. So our master database is about 1 terabyte. And we use the read replica for just analytic queries.
Okay.
So the settings we have is we set max standby streaming delay and archive delay to 30 minutes.
Mm-hmm.
The idea being is that long-running queries, at least they've got 30 minutes to run. And then, so we didn't actually set the hot standby feedback parameter. We just set that as off. Should we have done it the other way around?
So the question is regarding hot standby feedback and the max streaming delay. I would absolutely turn your your hot standby feedback delay on first. If you're going to set your archive delay, I'd set it down to like 60 seconds. See if your hot standby streaming delay will fix most of those problems.
Because I thought it'd be better that way than letting, I didn't want the slave actually impacting the master at all. I mean, I need to do it. It was more important. The master, I was afraid that the slave would start sending back feedback for some normal query that somebody could run for a day. Now, there's no way I can kill that. Of course, I can just do a timeout.
Another way to handle that would be regular vacuums on your master. If you can make sure that you're running auto vacuum and tuning it so that you get a rotation between what the queries are holding up on the slaves versus what the master's actually able to rotate, that'll give you, and just watch your bloat. Do you have a PGStat tuple installed? PGStat tuple, it's in the additional supplied modules.
It's not available yet on AWS.
Oh, you can't just go add.
No, it's not. It's supposed to come imminently, the product manager said, but no, it's not.
I'm so sorry.
Thanks.
Yeah, PGStat tuple is your friend. It'll tell you the percentage of dead tuples, both in tables and in indexes, and that's something you want to watch very closely if you have hot standby feedback enabled. Short of knowing that, there's some queries that can give you information based on the PG catalog tables, information schema. They're very large and nasty queries. PGStat tuples by far easier. But you'll probably want to look at the hard way to grab that information and monitor your auto vacuum. But hot standby feedback is probably definitely going to. So the first iteration of streaming that we implemented, we didn't have hot standby feedback on, and it made the slave practically unusable. It was the only way to actually make a slave a valid read slave. And as much as you increase your streaming delay, it's not going to affect it the same way. So you really need hot standby feedback on.
Sorry, last piece. What rate does the feedback work at? Does it tell you, like, don't apply any changes for these specific tables or the blocks, or is it just don't apply anything above this high watermark for the transaction TOD?
So I'm going to preface the question with how does the hot standby feedback work exactly with I'm not one of the developers. However, to the best of my knowledge, is that the slave will report what it's actually looking at. I'm running this query and stop the cleanup on that table or that range, and it has to do with the frozen ID. So when the frozen ID is set to a certain point, the master can go clean up everything before that. And so I believe, I could totally be wrong, it has to do with setting the frozen ID. There's a couple people who know that much better than I do at this conference. I would seek them out. The guys from Crunchy Data are particularly good at that. Anything else? Man, I'm used to so many awesome horror stories at this talk. I mean, I've got my own, but it gets better every time I give this because people get to tell me what went wrong on their systems. And no one likes hearing more than a catastrophic failure and why it happened. So that's all. I'm going to let you out quite a bit early, actually. Thank you all for coming, and I enjoyed talking to you.